Hear you
Welcome
now.
back, Will.
Yay. Sorry about that. So I posted that link to the YouTube video in case anybody wants to go there and watch from there. We'll be watching the comments on YouTube too, but the main reason I wanted to leave it was because it turns out there's a bunch of stuff you can't do on YouTube until you have 100 subscribers, and we would love for anyone who's willing to subscribe to our YouTube channel. We promise not to put dumb stuff on there. But yeah, I think that's all I wanted to say, and then we should start.
Okay, let's start. So welcome everybody to the Salt Lake City.net user group. We are very pleased to have Steve Smith with us, who's going to go over clean architecture with ASP.net. And then we do have some prizes. You will have to fill out a survey to get those to qualify, I guess, to receive the prizes. That's how we're figuring out who they can go to. And then we'll end at 7 o'clock. So like I said, we will have to have you enter for the prize. I'll give you the link to that in a little bit. And in the survey that we'll have you go to enter for a prize, we'll request that you rate our speaker. And if you have any questions, if you'll use the Q&A in Zoom and the chat on YouTube, and we'll be monitoring those to answer your questions. We're very grateful to our sponsors, Health Equity and Tech Systems, for our prizes. And Steve Smith is an entrepreneur and software developer with a passion for building quality software as effectively as possible. Steve has published several courses on Pluralsight covering DDD and solid design patterns and software architecture. He's a Microsoft ASP.NET MVP and insider, a frequent speaker at developer conferences, an author, and a trainer. Steve works with companies that want to avoid the trap of technical debt by helping their teams deliver quality software quickly. Steve and his team have been described by clients as a force multiplier, amplifying the value of existing development teams. Steve's client list includes Microsoft, Quicken Loans, Celina Insurance, and many other satisfied customers. And without a further ado, I'll turn it over to you, Steve.
Thank you. Thank you. Let me see. I should probably share my screen. So let's do that. Hi, everybody. Hopefully y'all can see applying clean architecture title slide. Good. All right. Thank you very much for the introduction, Bree. I'm very happy to be here. I was hoping to do this in person sometime. I've been coming out to Salt Lake City pretty regularly for the last couple of years, it seems like, but never on quite the right date. So given the current coronavirus situation, this is the best we can do is a remote meeting. I'm coming to you from Ohio, where it's odd weather for April. We've had snow and hail today, even though yesterday it was 70 degrees, but that's kind of how Ohio tends to be. If you don't like the weather, don't worry, it'll change. Today I'm going to talk to you a little bit about clean architecture. I'm going to have some demos. I'm going to use ASP.NET Core. I'd like for this to be kind of interactive. I know that's difficult to do sometimes remotely, but with the Zoom software that we're using, it should be pretty easy to raise your hand, ask a question. I'm happy to stop and answer any questions as we go. I think it's more interesting that way. So let me just get started, and then I have a few questions in just a second. So I usually have a clicker, and I don't have a clicker because I'm sitting at my desk. So I'm trying to figure out the best way for me to go forward on the slides. I guess that'll work. All right. So literally 10 minutes before starting, my twin 5-year-old boys were, upstairs refusing to go to bed and screaming. And so right after they fell asleep, and I was like, yes, I can go make those last couple tweaks to my slide deck and be ready to go. I took this quick picture of them. So this is Caius and his brother Caspian, who hopefully are still upstairs being quiet. I'm in the basement, so if they are up there yelling, their mom or sister will have to take care of them for now. If you want to learn more about any of these topics that we're going to cover today, specifically clean architecture, the easiest place for you to learn more is going to be my DDD fundamentals course that I did with Julie Lerman. And you'll find that on Pluralsight. Pluralsight actually is free for all of April. And so if you don't already have a subscription, you can access this totally free of charge and check out that course. It's actually due to be updated probably later this year to .NET Core. This one's using .NET Full Framework, but all the principles apply. I also have a sample that we're going to review a little bit later on in this presentation, but there's a sample called eShop on Web that is a reference application that I wrote and I maintain for Microsoft. So it's Microsoft's sample. I'm the main contributor on it, and you'll find it on GitHub. If you search for eShop on Web, just in Google, you'll find it. It comes with this ebook, 120-page PDF that you can also get for free. So you'll find this either at the link there, the architecture.com or ardallis.com architecture ebook link, or if you just go to the eShop on website, it's right there in the README for the GitHub repo. My main thing is doing training and mentoring for teams, usually remotely, but sometimes on site in other circumstances. So if you'd like to hear from me more with your team, feel free to reach out to me on ardallis.com. And for individuals, I also do career coaching and mentoring through devbetter.com. So you can check that out as well. I also have other ways that I give out free content. So if you just want to hear more from me for free, you can sign up for a newsletter I send out every Wednesday, or listen to my podcast at the links here. And then I've been trying to stream, usually on Fridays, occasionally other times on twitch.tv. And pretty much anywhere you'll find me as Ardallis, and that's because there's a lot of Steve Smiths out there. In fact, I'm in a Facebook group called all the Steve Smith Brotherhood that anyone that's named Steve Smith can join, and there's several hundred members, which is, I'm sure, is just a tiny fraction of all the Steve Smiths. So because there's so many of us, I have a more unique name, which is actually a name I used to use when I was playing role-playing games and later on online games. And usually it's available. So you'll find me almost everywhere as Ardallis. All right, so let's roll into the actual meat of this presentation and talk a little bit about clean architecture and how to apply it using ASP.NET Core. And so to kick things off, because if we were in person, I would say to the audience, do any of you have any questions before we get started? And almost always, nobody will raise their hand, which is kind of strange because you'd think if they were interested in the topic that they would know something about what they wanted to know, but nobody wants to ask because they don't want to ask a stupid question, or they don't want to ask the wrong thing, or they want to wait and see what I'm going to cover. And so what I've found to be helpful is to start out with some questions of my own that kind of seed the presentation. And so here's the things that you should know when we're done here. All right, so the first thing that we're going to talk about is why do we separate applications into multiple projects? Because that's going to play heavily into clean architecture. And when we do that, we want to know, like, well, what do we think about when we're doing that? What are some principles that we should apply when we organize our software into different modules? And when we think about that, we want to think about how does the organization of our application solution, if we're talking about Visual Studio and Microsoft Stack, you know, when I say solution here, I mean the solution and the project files that belong to it. How does that impact the coupling in our application? And we'll talk more about coupling as we get going. We'll talk about some problems that result from certain common approaches. Many of you, I'm sure, will be familiar with some of these problems. And then we'll talk about how clean architecture addresses these problems and hopefully mitigates them. And then specifically, ASP.NET Core we'll talk about a little bit as well, because it has a lot of features that its predecessor, ASP.NET 4 or full framework, whatever you want to call it, did not have. And so ASP.NET Core is definitely a step in the right direction for leveraging and applying some of these principles that clean architecture offers in the Microsoft development space. All right, so let's talk principles real quick. The first one, and probably the most important one, is called separation of concerns. And if you look closely at this refrigerator, some things may jump out at you as being a little odd, because this is an example of not separating your concerns. A few years ago, company that I worked for, we decided to sell software craftsmanship calendars. And so they would have either design patterns or anti-patterns, principles, things like that in them. And so this is one of the images from that calendar. And we actually set up our refrigerator in our office for this shot. And we decided we wanted to mix a bunch of things in the refrigerator that really didn't belong there. Because when you're talking about having your steaks there ready to grill, and other, produce and things, you probably don't want your pipe wrench and your plunger and your Drano to all be sitting there with it. And so the idea with separation of concerns is that you don't want to let your plumbing code pollute your software, especially your other concerns, your UI concerns, your business logic, your domain, those types of things. All right, so separation of concerns is a big one. And when you're following this principle, basically you want to avoid mixing different code responsibilities in the same place in your code. That might be in the same method or in the same class, or even potentially in the same project. Now, some of these principles, they're not written in stone. It's not like you have to always adhere to them 100% all the time. But as a project gets larger, the penalty you pay for not following them increases. Right. So with a small project, you could probably just put everything in one project and you'll be just fine. Maybe you just have some folders to split things up, if that. Right. But as it gets larger and as you have more people working on it, or it has, more concerns or broader scope, it becomes more and more important to follow the principles that we're going to cover here, including separation of concerns. Okay, so the big three concerns that you're probably familiar with are data access, business rules, and if you're following domain-driven design, this would be your domain model, and then whatever your user interface might be, whether that's an actual UI that the user interacts with, or if you're just building a set of APIs, it would just be your web API interface that you would expose. Okay, so then the next principle that is closely related to separation of concerns is the single responsibility principle. And this principle says that you should avoid tightly coupling your tools together. If you've ever bought something that was like an all-in-one device, you maybe have discovered that it wasn't great at any of them, as well as a fit-for-purpose tool would have been. In this example here, the picture is showing an actual wired mouse. That's also a Swiss Army mouse. And so, the idea that you might need a Swiss Army knife while you're using your mouse at your computers is probably far-fetched, right? You probably only want a mouse some of the time and a Swiss Army knife some of the time. And there's other things like this too. Like you might see a television that also has a DVD player or older, maybe a VCR like attached to it. Well, as soon as either one of those things breaks, the whole unit is basically shot at that point, right? It's much easier to replace and upgrade a system if you have a television and then separately you have a VCR, because a few years down the road, maybe you want a DVD player, and a few years after that, you want a Blu-ray, or after that, you want an Xbox. It's easy to swap those things out if it's not tightly coupled to the screen that goes with it. And so that's what we want to do with our software as well, is keep our software modular and separate so that we can upgrade it and swap it out and replace it more easily. So single responsibility works in tandem with separation of concerns. If you're familiar with solid, this is the S in the solid principles. And it's the thing that says your class should only have one reason to change. All right. And I saw a comment flash up there, but somebody else covered it, I think. So I'll just keep going. Moderators, if you want to just yell at me if there's a question that I should stop for, just feel free to interrupt. All right. Thank you. Okay. So then the next principle is another fundamental one, and it is the don't repeat yourself principle. And the don't repeat yourself principle, or the DRY principle, says that repetition is the root of all evil in your software, and you should strive to avoid having the same concept duplicated in many different places in your application. There's different ways that you can follow don't repeat yourself. If you have repetitive code, a lot of times you can refactor that into functions and then call those functions instead of having that code duplicated. You can group those functions into cohesive classes. And when I say cohesive, I mean that the functionality and the data that it operates on all belong together. They all work together at the same level of abstraction. They're all dealing with the same responsibility. They belong in that one unit of that class. Now, as we're following don't repeat yourself, it makes sense to organize our code in some fashion. So we've taken the low-level code and we've put it into functions. We've taken those groups of functions, we've put them into classes and objects. From there, we're going to use folders or namespaces, and we'll group these as well based on whatever criteria makes sense to us, right? There's a little more art than science here, but generally you're going to want to separate them based on their responsibility, their level of abstraction, whether or not they're concerned with business logic or UI or what have you. And eventually, once you have enough of those, it may make sense to further group those folders into projects. Now, there are some other folks that will say, you know what, projects are just a pain. You really don't need more than one project. If you're not going to be distributing your assemblies separately, there's no reason to have multiple projects because you're just deploying the whole thing as a monolith anyway. And And that argument, I can kind of buy, but the biggest thing that I like about projects is that they help me from doing stupid things. The biggest thing that a project lets me do is say that everything in project A depends on stuff in project B. And as a consequence, nothing in project B can ever depend on anything in project A. And we'll talk more about that in just a moment, but you can't do that easily if you have one project in just folders, right? And so there won't be anything to prevent someone accidentally or on purpose from creating dependencies that go every which way within your application. All right, so then the next thing we want to talk about is the dependency inversion principle. This is the D in Solid, and really, I think it's probably the most important of the Solid principles, so I would put it up front, but then it wouldn't make a very good acronym as far as being pronounceable. So it's the last one that you ever see covered when people go through Solid in order, but you should definitely wait for the end and see what's after the credits, because this one is like the best one. The idea with this, and the picture here is that you've got a lamp, and instead of using a plug and plugging it into an electrical outlet, you are just going to take the wires from the lamp and solder them into the wires inside your wall. That would not be very modular. It certainly wouldn't be plug and play, right? So it would be a much more difficult task at that point to swap in a different appliance, or to take the lamp and plug it in somewhere else, either way. So the idea with the dependency inversion principle is that both your high-level classes and your implementation detail classes should depend on abstractions. And when we're talking about .NET and C#, generally when we talk about abstractions, we mean interfaces. We could be talking about abstract base types. We could be talking about just a class that, every class is an abstraction to some extent, and you could extend it. But generally, we're talking about interfaces because they're the easiest thing for us to use, and they're the most flexible. That we can have multiple inheritance against interfaces. We can't do that with classes. So there's a bunch of reasons why generally interfaces are the thing we want to use. All right, now related to this, if you're going to use, well, let me back up for one sec. The other thing that this is saying in the title here is that we want to inject these dependencies. Okay, so as you talk about classes that have dependencies on other things, those dependencies should be described as abstractions, as interfaces, and they should be injected somehow. They shouldn't be hard-coded. And so the way that you're going to do that is through dependency injection. And if you have any experience with ASP.NET Core, you're probably already familiar with dependency injection because it's built into that framework right from the start, which wasn't true of its predecessors. So that's one of the big steps forward for ASP.NET Core is it has support for DI built in out of the box. Okay, so when we're talking about doing this injection, there's a few different ways you can do dependency injection. The most common one is constructor injection, and that's what you're probably most familiar with. But you can also inject dependencies using properties or using parameters on methods. Generally, when we talk about dependency injection, we're talking about constructor injection. And that leads us to this next slide, which is all of your classes should follow the explicit dependencies principle. And if you're not familiar with that principle, I would encourage you to Google it. But basically, it says that your classes should be explicit about all the dependencies that they need. They should request those dependencies through their constructor so that any developer that wants to use that service can look at that service and try to new it up or just inspect its constructor and know immediately whether or not they have the things they need to work with that type. Otherwise, you run into the all too common scenario where you're working in a large code base. You don't necessarily know all the services intimately. You need to do a certain thing. You want to follow dry, so you don't want to reinvent the wheel, right, and build it yourself. So you figure somebody's already got a service that does this, and you quickly look around and you find a service that looks like it'll do the right thing. And you see, oh, it's got a default constructor. Perfect. I'll new it up and I'll call that method. And you build your code and everything works. And then you run it. And at runtime, it blows up. And it says, oh, I couldn't do my job because I needed this file. And then you fix that and you add some file somewhere and it's, oh, I couldn't do my job because I needed this configuration setting. And you keep playing whack-a-mole with all these dependencies that it didn't tell you it had. It lied to you and said, you can just new me up. I don't need anything, right? The constructor is the place where you can define all the dependencies that you actually need for your class to do its job. And that's what the explicit dependencies principle says, is make it explicit what your dependencies are in the form of the interfaces that your services need to perform their operations.
We do have a question.
All right.
It is, what is the maximum number of dependencies to inject in CTOR optimal number?
The optimal number of dependencies in the constructor. You can use a tool like nDepend and enforce the rules that you want to apply for this sort of thing. There's also Roslyn analyzers that you can use. I don't have a hard maximum. Fewer is generally better. And for most, I mean, your constructor is just a method. So how many parameters are okay to have on a method? Well, generally you don't want more than like 3, maybe 3 to 5. If you start getting into double-digit numbers, you're definitely in code smell territory. So, single-digit total number of dependencies would be ideal, and certainly have a very high tolerant or preference for the smaller number, right? So if it's got more than 3 or 4, I start thinking about refactoring it. But sometimes you can't get around it. Does that help? Hopefully. All right. Any follow-on question? All right. So
Here's a follow-up question.
Yep.
It's single responsibility.
Yes. That's the question?
That's the question.
It is an indicator oftentimes if you have a whole bunch of dependencies that you probably have more than one responsibility. It's not for sure, it's not definite, but the more dependencies you have, the more likely it is you're probably trying to do too much. And if you have a class that has 14 dependencies, maybe that could be 2 classes with 7 dependencies each, and they each have fewer responsibilities, right? That's very common to see, that you'll just extract out some methods into a new class, and redefine the 2 classes so that they each share or each have a share of the original class's responsibilities. And now you have 2 smaller classes with fewer dependencies that are also more cohesive. Because the other thing that happens quite a bit when you end up with a constructor that has 15 different dependencies coming into it is that that class maybe has half a dozen methods, and each method is only using a subset of those dependencies, right? So they're not even used by all the methods. And so by breaking that class up, you make it so each class could have fewer dependencies because it's only going to have the ones that it's actually using. Anything else?
Yeah, we've got another question. Any
right.
preference for DI framework in ASP.NET Core Greenfield app?
Start out with just the built-in DI container. It works fine for most applications, and there is some learning curve involved with choosing one and getting your team to all understand how it works and things like that. So, if you're not building something that is going to be huge, and you don't necessarily need any features that aren't in the box, then just use the in the box one, right? Just use what you see in configure services and startup.cs. However, to actually answer the question, my preference is AutoFac. Currently. So I don't have any features really that AutoFac doesn't have in terms of limits that I've hit with it. I did just open an issue with them like literally 2 days ago to ask if there was a way to unregister a service, but their team was super responsive, and within like an hour I had like 3 different suggestions of ways to do what I needed to do without adding that feature. So even though they didn't give me what I wanted, they gave me the solution to my problem. So and I can tell you that they're very on the spot with responding to issues. So AutoFac would definitely be my pick at the moment. Anything else?
I'll ask
All right.
one. Do
Yep.
you recommend a particular pattern for dependency injection when the dependency is optional?
Okay, so if you have an optional dependency, what pattern would I recommend? Don't ask for it. When do you have an optional dependency? Can I have a scenario? Like, let's say you have a shopping cart method and the dependency to send emails to the customer is optional because maybe they didn't actually succeed in all the other steps needed to check out, right? Like, are you talking about something that conditionally only happens sometimes, or when else would it be optional?
Just an example, don't know.
Okay. Yeah. Well, I think I'd need a scenario, but generally, if you're ever going to need it, sometimes even conditionally, you have to inject it, because otherwise, what are you going to do?
Yeah, I've often heard the suggestion that the constructor is for all required dependencies, and then you use property or method injection for optional dependencies. And I don't remember the cases where I've ran into those.
Okay. Yeah, I very rarely use method or property dependencies. Property dependency injection, the problem with that, and the reason why I don't recommend it, wholesale, is primarily that you can't ever be sure that an instance of your service is ready to go, right? You have to check and see if those properties are null or not, or you have to build a bunch of logic inside the service itself to do null checks of those properties. Whereas if you do constructor injection and you only have constructors available that require those dependencies, and you follow explicit dependency principle, then you always know if you have an instance of this thing, it must have its dependencies, right? There is no way that it doesn't. And so it makes it a lot easier for you to reason about your code, and it simplifies your code dramatically because you can just be confident that it works. With method injection, the problem with that is that you're kind of just kicking the can down the road, or upstream if you prefer, where now the calling code needs to have that thing in order to call this method. And so all of a sudden it needs to request that from somewhere, and probably it's going to do it through its constructor, but it may not even use that service, right? So now you have a type that you have to inject into service A that it doesn't even use, but it needs it to pass into a method on some other service B so that service B can do something with it. And that's just tightly coupling A to the implementation of B, and having to know way too much about the internals of how B works, right? So that's the main reason why I don't support or prefer method injection. So some more DI tips there, I guess. Any other questions on dependency injection or inversion? All right. So a corollary to all this, where the idea here being that your services should require what they need through their constructor. Those requirements should be defined as abstractions, so they're probably interfaces. Those interfaces need to be defined somewhere, right? You got to put them somewhere. Sometimes what I see teams do is they'll say, okay, well, I've got this interface that does, customer service or whatever, and they'll have the sit literally right next to, sometimes even in the same file, as the implementation of customer service that has all the details of how it actually works. And that works, right? I mean, they can reference one another, but it doesn't really give you the benefits that we want in terms of the dependency inversion principle, because anything that depends on the implementation details also depends on the abstraction and vice versa. And we'd like to be able to invert that and say that, no, the things that depend on the abstraction don't know about the implementation details. And we'll see that in just a minute. So these interfaces have to be accessible by the low-level implementation services, the things that actually do the real work, the high-level business services, the things that orchestrate how things are working and don't necessarily have to know about the details, and the user interface entry points, because that's where you're going to wire all these things up. All right, at runtime, you can't run an interface. So somewhere you have to actually say, when someone asks for this interface, I'm going to give you an actual thing. The user interface entry point is typically where you do all that wiring up. And in ASP.NET Core, this happens inside of configure services. Okay, so let's talk a little bit about dependency graphs. If you don't use dependency injection or abstractions at all, then your code is going to look something like this. And if you remember, probably when you first learned how to program and you were writing console applications or whatever it might have been, it was probably something fairly straightforward where when you needed to use some method on some other type, you just created it. You just newed it up and then called its methods, right? And so at compile time, you would have class A would reference and instantiate class B, which in turn would reference and instantiate class C. And your dependency chart looks like what you see on the left. At runtime, if you look at a breakpoint inside of a method in class C, your chart is going to look exactly the same as that compile time chart, right? Your stack trace. So you're going to see that some method on class A called some method on class B, called some method on class C, and that's your control flow as you debug through this application at runtime. And it may never have occurred to you, it didn't occur to me for a long time into my journey as a software developer, that these two things didn't have to be in lockstep with one another. They could actually diverge. And as soon as you realize that, it opens up a door to a whole lot of different patterns and approaches and things that you can do to make your software better. And so if you are using abstractions and you have this modularity built into your system, now at compile time, class A references interface B and has no knowledge whatsoever of class B. And class B implements interface B, so it has to have that reference. And it also references C, but now it references C through its interface, not the class itself. And so class B doesn't know anything about class C either. At runtime, though, it's exactly the same as it would have been otherwise, right? Where class A calls a method in B, which calls a method in C, and everything runs the same way it did before. But I can now swap in, a different version of B or a different version of C anytime I want to, and it makes my application much more modular. It also makes it much easier for me to test because I've added seams into the code that will let me break this up and allow me to test different units of it in isolation from the rest of the application. All right, so when we're talking about the architecture for your system, and we'll get into some details here in just a moment, the main thing you want to do is you want to make it so that the right thing is easy and the wrong thing is hard. Because developers are creatures of habit and we're lazy / efficient, whichever you prefer, and we want to just get stuff done as quickly as possible and not have to go to extra effort to do it if we can avoid it, right? And so by making it so the right thing is easy to do and the wrong thing is harder, you kind of force developers into the pit of success. Because the alternative is the pit of despair, and none of us want to go there. And we've probably, most of us that have been around for a little bit, we've been in projects like that. All right, so to make the right thing easy and the wrong thing hard, your UI classes shouldn't depend directly on infrastructure classes, because that means that you're not following dependency inversion principle, and your UI classes now depend directly on low-level details that are in this infrastructure that I define as these infrastructure classes. So infrastructure to me is stuff that depends on things outside your program, right? It talks to the file system, it talks to a web service, it sends an email, it talks to a database. Those are all infrastructure because they aren't dependent on your code, they're dependent on external resources. All right, so how can we structure our solution to help enforce this rule, this notion that your UI classes shouldn't directly depend on that infrastructure stuff?
Steve, we had a question come in from YouTube, and I'm guessing it's a little bit behind the Zoom.
Okay.
The question is, what are your thoughts on transient versus singleton dependencies in .NET Core?
What are my thoughts on transient versus singleton dependencies? Well, first, it is so awesome now that in .NET Core, you can just define whether something is a singleton or not by just saying, as singleton inside of configure services or your DI container. And so you never, ever have to actually implement the singleton design pattern on a class itself directly ever again. So that's awesome, because singleton is pretty much an anti-pattern as the design pattern goes. In terms of object lifetime in ASP.NET Core, it should be fairly rare. It's definitely fairly rare in my experience with my clients to implement things as singletons. So the default typically will be transient. Some things will be scoped, which wasn't mentioned, but that's the other lifetime that's typically used. Anything that has to do with entity framework, EF Core, should be scoped. And that means not just the DB context themselves, but also any of your classes that work with those. So if you're using repositories, they should be defined as scoped as well, so that they match up with the DB context that they're using. The reason why I say that you typically don't want to use singleton is because there's not a lot of benefit to it in the first place, and it can cause side effects that aren't good, right? It can cause problems with threading and race conditions. It can make it so issues occur in your system that aren't what you would expect. Developers that are working with it may not realize that it's actually a singleton, because in their code, there's nothing that indicates that. It's purely a thing that was configured at startup. And so if they're assuming that it's a transient instance, then they could easily do the wrong thing. Most services that you're going to inject in an ASP.NET Core application should be stateless, meaning that they shouldn't have any state on them, any properties that matter. And so anytime you need some logic on one of them, you should just ask for it through your constructor, call a method, and then let it get disposed. And so whether that type of thing is a singleton or a transient or a scoped lifetime really shouldn't matter. Now, theoretically, you'll have more garbage collection happening in a highly contentious app if you're using transient versus scoped versus singleton. And for things that really do take a lot of expense to create, like if you're using nhibernate, and Hibernate has a session manager, is that the right word? I think it's session factory. And session factory is very expensive to create the first time you use it. And so if you do that as transient, you're going to just destroy your application's performance, and every single request is going to take seconds, if not minutes. But aside from certain things like that, where the class itself has some very expensive creation behavior, you're probably fine to just use the default of things being transient. Does that make sense? And if they're behind, it'll probably be 5 minutes before they tell me if that made sense. So I'll just keep going and assume that it was brilliant and they loved it. Okay, so the next thing that we're talking about is making things the right thing easy, the wrong thing hard. So we also don't want our business domain classes to depend directly on infrastructure. And we'll talk about why in just a second, but we want a solution that can help with that can help developers follow that advice and not go against it either on purpose or by accident. And then we want to follow the dry principle. So certain cross-cutting concerns like query logic, validation logic, different policies, how we do error handling, how we do logging. Those are often a problem where there's copy paste code happening with this. And there's a lot of different ways to do the same thing. And so there might be patterns that we can apply that will make it easier to avoid that repetition, things that are better than just copy pasting, things that are actually easier for a developer to do than copy pasting, which is a hard barrier to get over because copy paste is always right there, right? Control C, Control V is really fast. But we can try and find ways to make it so even that is harder to do than the right thing. Okay, so let's talk a minute about different types of architecture styles. And first off, let's talk about this classic N-tier architecture. And the N-tier architecture, or N-layer if you prefer, because tiers generally refer to actual different servers or machine boundaries, whereas layers are more logical boundaries within the application. And generally these applications would get deployed as a monolith on a single machine, a single web server with a UI layer and a business logic layer and a data access layer all together living on that same machine. But either way, N-tier is definitely a more common term than N-layer. Here is this beautiful diagram from the MSDN website back in 2001. It's almost 20 years ago. It was also in the very first conference presentation that I gave in 2001 in September, like 2 weeks after 9/11 happened. It was a weird time. This time kind of reminds me of that in some ways. There were, I think, 6 people in my session because nobody was going to conferences or flying anywhere 2 weeks after 9/11. But I gave a talk on how to do N-tier applications in .NET then. And so this was early days for .NET, and my experience was primarily with ASP and COM. And I was talking about how over here on the far left, you have everything together in an ASP page or in a VB6 form or whatever it might have been. And there wasn't a lot of separation. And so you would move toward the right and kind of break out these different layers, right? And you typically would have the data access layer would be the first thing folks would pull out. And then if it wasn't just a CRUD application and you had some business logic, you would also pull out a business logic layer as a separate thing, a BLL and a DAL. And each one of these would talk to a data source. Over the years, as often happens, right, guidance has shifted where N-tier was better than no tier, right? It was better than just having all your code as spaghetti mixed together and no separation of concerns at all. But there weren't any abstractions here. And because there were no abstractions, the control flow was very rigid. All the dependencies flowed in one way. And so you have this data access layer depends on the database. The business layer depends on the data access layer. And so that transitive dependency means it too depends on the database. User interface layer, same thing. It depends on the database by way of these other projects. And so everything depends on the database. And what you end up here is a system that is very difficult to unit test. It's very difficult to find any seams in the system that you can test in isolation from the database. And so my early applications that I built for my early businesses, they use this architecture because of course they did. That's what Microsoft recommended. That's what I talked about in my talks. And it was better than what I'd been doing previously. But it had this pain. And so when I was writing automated tests and I was doing continuous integration in 2005 or in 2006, it was painful because I had to have a database and I had to reset that database every single time a test ran. And if I ever needed to add a new test that needed some new data, I would add that data to my test script and other tests would break because they didn't plan on that data being there. Every single test was coupled to every other test because of the way everything depended on that database and a single test script to restore that database. It was the pit of despair as far as pain goes. And so, this was something that I didn't know how to get around until I learned about Solid and I learned about abstractions and depending on interfaces instead. And dependency injection really changed how I wrote that software. And so writing this code and working with this just sometimes will just suck the life away from you as you're trying to figure this out because you want to be just getting work done and instead you're fighting with your architecture essentially. And to use another Princess Bride reference here, right, it would just suck the energy out of you and you would really rather be doing something more fun than fighting with the database. Okay, was there another question? I thought I saw one flash up. Nope. Okay. So then domain-centric design and clean architecture is the solution to some of that pain. And if it's not a magic silver bullet, it's not a magic bullet. It doesn't solve everything. There's some pros and cons to it, but I've found it to be much more preferable to using a data-centric architecture for all the applications I've been building for the last, I don't know, 15 years. And so you've got a domain model if you're following domain-driven design. And inside of your domain model, you're going to have a model of the thing that you're trying to solve. And the model is going to be persistence ignorant, meaning it doesn't know how it's persisted, if it's persisted, doesn't care, right? It could have a database behind it. It could be a SQL database, could be a Mongo database or a NoSQL database. It could just be stored in XML files, who cares, right? But it's got all the logic and state of your system that you need to work with. It also defines all the interfaces for working with these domain objects. So if you have services, they'd be defined in here. If you have different interfaces you want to use to represent sending messages or notifications or fetching things to and from persistence, those would all live in the same domain model. And then everything in the application now depends on this, right? So the infrastructure that has the implementation details of how I'm going to send a notification or how I'm going to fetch something from persistence, that depends on these interfaces. And of course, all of data access lives in infrastructure, and all of the user interface depends on the domain model as well. Okay, so in clean architecture, which is the latest name for an architecture that's been around for a long time, you may have also heard of onion architecture, which Jeffrey Palermo made popular 10 years ago, I think, in the .NET space. Hexagonal architecture or ports and adapters, which have been around even longer, like probably going on 20 years at this point. These all correspond to essentially the same idea in terms of the architecture. So this is a diagram from the onion architecture approach, and it uses circles to represent this and layers because onions, just like ogres, have layers. And inside of this, you've got a core at the very center, and that is your domain entities. That's the most important thing about your application you're writing. That's the crown jewels, right? And so you want to protect those from anything that would make them more coupled to infrastructure, more difficult to test, et cetera, right? You want them to be have no dependencies on anything else in your system so that they're easy for you to test and change and work with and modify. And as you learn more about your problem space or you get new requirements and you decide you want to implement them in a different way, you can do that because nothing is tightly coupled to them that's going to make that difficult. You're going to access those with repository interfaces. So we'll talk about the repository pattern. You don't have to use the repository pattern. You could call it something else if you want. You could have a service that fetches these, but you have some type of interface that's responsible for persistence. And generally, those interfaces, those types, are referred to as repositories, at least in domain-driven design circles. And then you also will have service interfaces there as well for defining other operations, whether business operations or lower level things like sending emails and things like that. Everything in those middle circles, the blue and green ones, is part of your core project in clean architecture. It's the center project, it's the domain model that everything else is going to depend on. Everything else in the purple is a whole bunch of different projects probably, right? So you might have your tests down there at the bottom, that's in different test projects. You've got your UI over on the left, whatever that might be. You have infrastructure that actually has implementations of these interfaces referring to this. Maybe you have services exposed using WCF, this is an old slide, old diagram, or REST or gRPC or whatever you might be using today. All those things depend on that middle section, that core. All right, now this is hexagonal architecture, also known as ports and adapters, right? You can kind of guess why it's called hexagonal architecture. It's because somebody made a picture like this and they decided they'd use hexagons instead of rectangles. And boom, now we've got hexagonal architecture. But also notice on here, those little purple circles, those are ports, right? And so those are ports just like in the wall of your house, you've got an electrical outlet as a port, right? And then you've got different things you can plug into those ports. So if we look at the upper right quadrant here, this infrastructure layer, we could have this internal persistence port that knows how to store and retrieve the objects in our domain layer. We could implement that using an in-memory object store, maybe just for test purposes. Or we could use an RDBMS, a SQL Server object store instead, and actually store it in a real database. And we could swap either one of those out. We can plug them in and remove them anytime we want. And they both will do the same thing. And the domain layer will be none the wiser. right? The UI layer will be none the wiser. Yeah, this whole system will still work the same way and doesn't care what is plugged into this port, as long as it does the things that the port expects it to do, right? As long as it follows the interface and implements the interface.
We do have a couple questions.
Okay.
They might have happened in the other slide instead of this one, but Evan asked, where do controllers fit in here?
In here, they'd be in the UI probably, if this is what he was talking about. And we'll talk more about ASP.NET Core in just a second. We're almost there.
Okay. And then the other question is the repository pattern preferred over CQRS?
They're not mutually exclusive, but you can use either one. Yeah, you can use repository with CQRS and it works fine. You can also just, if you're going to use very thin vertical slices, which Jimmy Bogard likes to talk about, you can avoid some of this and still produce clean code that's going to be easy to test and easy to work with. It won't necessarily be as easy to unit test, but you can still write integration tests that will do the same thing and will probably be not too much slower than unit tests would have been. So there's some style preferences there, but either one can work.
Okay, and then one more question says, I always get confused among the terms domain model, business model, object model. What are your thoughts?
They're mostly words for the same thing, right? Your domain model assumes that you've done some work to actually model the domain, meaning that you have both the data, the behavior, the events, the things that occur in the actual problem space. You're modeling those in your code, and that's the solution space, right? And so your domain model represents the entities and the values and the events and all those things that correspond to whatever the problem is you're trying to solve, right? A customer trying to add an item to a cart and check it out and pay for it with a credit card, or some blog application or whatever it might be, right? That's modeled by those types. Your object model is kind of the same thing. Usually your object model to me is more vague, right? You could have an object model in the infrastructure layer. You could have an object model in your UI, right? That's just some objects. And so it's not necessarily tied to the domain layer or your business concerns. When you talk about business objects, business layer, business model, I don't hear business model as often, but business layer, that may or may not correspond to a domain model, because a lot of times a business layer is not stateful. Frequently when especially if you're following old N-tier code, the business logic layer was often just a pass-through to store procedures or something in the database, and didn't have the same richness that a domain-driven design domain model would have, right? You wouldn't just new up your business layer and be able to test it all by itself and have it interact independent from persistence or any other layer that would be dependent on. So that's to me kind of like some nuanced differences. They can almost be used as synonyms, but I think there are differences, at least in how I interpret them. And hopefully that was helpful. Any more before I keep going?
Yes. Does the domain model include the repository or just the entities themselves?
The domain model includes the entities and the abstractions, of which the repository is likely one. So it includes the abstraction for the repository. It doesn't know anything about how that's implemented, right? So this port here on the domain layer is the abstraction for a repository, right? A persistence port is a repository interface, right? Those are words for the same thing. You might not choose to call it a repository because a lot of circles are saying repositories are bad. But if you have an interface that represents persistence, that's basically what a repository is. And then the implementations live in a different layer, right? So the infrastructure layer, or in what we're going to see, the infrastructure project, is where the implementations of those interfaces live. All right. Let me talk a little bit about clean architecture then. So the first rule of clean architecture is you do not talk about clean architecture, which I'm breaking right now. But actually, that's the rules for something else. Sorry. The first rule is that the application core, the core project, contains the domain model. Okay, so that's where all the stuff that's to do with your business logic, your entities, those all live in the domain model, which lives in the core project. All your other projects depend on the core project. If you're thinking of it in that circular diagram, all the dependencies point inward, and that's why we call it core, is because it's at the center of everything. It didn't help efforts with this naming that ASP.NET and .NET decided to call their thing core, not necessarily thinking ahead that eventually it would grow to be bigger than its predecessor, because initially it was like, oh, it's just the core of .NET, it's just a small little thing, and now it's like, no, it's bigger than .NET, and so we'll hopefully get past all that with .NET 5. But in clean architecture, the core is called that because it's the center of your application. It's where everything else depends upon. Your inner project should define all your abstractions, your interfaces, typically. There's a few exceptions, we'll talk about those. Your outer projects, like infrastructure, will implement those interfaces. And so if you ask a question, where do repositories live? Well, the answer is 2 places, right? The abstraction lives in core because it's an interface. The implementations live in infrastructure because that's where implementations go. You should avoid direct dependencies on the infrastructure project from everywhere else. You might have dependencies on it with integration tests, probably, and you might have dependencies on it from startup.cs. Probably you have a dependency on it from startup.cs if you just use the built-in container in ASP.NET Core. But you should strive to avoid having dependencies on it from anywhere else in your UI project, right? So you shouldn't have controllers that know about things in infrastructure. If you look at your namespaces in a controller and you see using my project.infrastructure as a namespace, that's a smell. That's telling you right away, oops, somebody added a reference to something they shouldn't have. I'm talking to things in infrastructure from a controller, from my UI project. Some features of clean architecture: it's framework independent. This will work with C#, it will work with Java, it'll work with Python. It doesn't really matter. Doesn't rely on any proprietary software. It's just a way of organizing things. Likewise, it's database independent. It doesn't care what database you're using. Doesn't care if you're using a database. It's agnostic to databases. And same thing with UI, right? This works whether you're building a Windows service or an Azure function, although it might be overkill for an Azure function, or a web API, or an ASP.NET Core, standard web application. It's very testable. This is probably my favorite feature of it. Everything that you build following clean architecture is very easy to test. And so if you're like me and you think that unit tests are valuable and automated tests in general are valuable because I'm lazy and because developers are really expensive. And so why should a developer do the same repetitive task multiple times to test that something works when computers are awfully good at that? And we can actually have a computer do that as part of our process before we even ship code to the next stage of our production cycle. Tests make a lot of sense. And so clean architecture is optimized for testability. Okay, so any other questions before I keep going?
Yeah, there's one question.
Yep.
It's from Nemke, who's in Europe. Says, can I access core from all layers? E.g., the controller knows about domain, or I need to go through application layer and DTOs.
Everything knows about core. If you want to use an application layer and say that your UI layer only interacts with an application layer that has certain stories or features defined, that's fine. That can be helpful. I'm not saying never do that, but there's nothing that would prevent you in the actual solution from also just bypassing that and going to core, right? If you have an application layer that you've chosen to use, this won't necessarily protect you from getting to core because you're still going to have that transitive dependency on it. But yeah, typically, especially and definitely if you're not using an application layer as a separate layer in your system, everything should be able to get to core. And if you are, you're still going to depend on stuff that's in core, probably in the form of the entities themselves and things like that. I heard him mention DTOs. I wouldn't recommend necessarily having a whole separate layer that only passes DTOs onto the UI if we're talking about everything being in C#. Right? Now, if you're talking about like a front-end client-side application like Angular or React or something like that, and that's the UI we're talking about, then yeah, we're going to be sending DTOs over the wire in that case. And that's a different scenario at that point. But as long as we're talking about C# running in the same process on the server, there's not a whole lot of value to me of taking all your rich business objects and entities and then exposing them only to an application layer, and then having your controllers, have to map those, or have the application layer have to map those to DTOs for the controller to use. Somewhere you might have to do that mapping, especially if you've got a front end app that needs those DTOs. Typically, I do that in the UI layer. So I don't generally have a separate application layer for that, but you could. So hopefully that helps.
We had another question come in.
Okay.
What do you mean when you say avoid direct dependency on infrastructure layer except startup.cs? Does that violate core architecture?
I'm saying core should not depend on it. There's three main projects, which we're going to cover on another slide here in just a second. The
Okay.
three main projects in clean architecture are core, infrastructure, and UI, right? And so I'm saying that nothing should depend on infrastructure directly if it can help it, and sometimes you can't help it, right? So, but specifically core shouldn't depend on it, and in fact, we'll see it can't depend on it because infrastructure depends on core, and .NET won't let you have a circular dependency. So short of some reflection hackery, there's no way for core to have a project reference to infrastructure. Now UI, your web project, could depend on infrastructure, and typically it will in a default scenario, but you shouldn't use infrastructure references throughout your web project. You should limit those only to the application entry point, which is startup.cs and in configure services, right? So there you might need to know about those types because you might be saying, I want to add a transient service for iFoo that uses service, foo that lives in infrastructure, right? And so to do that wire up, you need to have that reference. But as we'll see in a minute, you don't actually even need to have that reference. There's ways around it.
We've got one other question. Do you recommend returning interfaces from methods on an interface?
Not usually. The most common one I see is folks that want to return back an iList instead of a list. And generally, I've gone down that path a bunch of times, and it's never really bought me anything. Because at the end of the day, I'm not usually returning lots of different types of things from that. It's almost always going to be a list. And so it hasn't ever, that extra level of indirection has only ever caused me pain and never really brought returns. So I would default to using implementations as your returns. And if you run into a problem with that, where you're actually feeling pain, then follow PDD. It's yet another one of those DDD type, whatever DD type acronyms. This is pain-driven development. So don't add extra indirection and abstractions until you're feeling pain. And then once you're feeling pain, react and refactor your code to address that pain. But short of that, keep it simple. Just return back a list, return back the actual thing that you expect to return back, and wait until that causes you pain to do anything about that.
Great. No more questions right now.
Cool. All right. So if you are already using a legacy architecture, something that isn't following clean architecture, and you want to refactor it, there's a few different options, right? The best choice is to start from a properly organized solution, and basically lift and shift your code from your solution into this solution that's already organized well for you, or just rewrite it if it's not too big of an issue to do that. Oftentimes that's not tenable. Next best is if you are starting from an application that only has a single project, your life is actually easier, right? The fact that you don't have it set up in such a way that you have UI depending on business layer, depending on data access layer. If all you have is one project with a bunch of folders, it's easier to split that out into core, infrastructure, and UI projects. The most difficult is if you already have a big existing application with 3 or more projects in a multi-layer architecture, and it does not have any abstractions, and it does not use dependency injection or dependency inversion. In that case, it's going to be the most effort to do this type of work. And so that's where you should expect to have to invest a fair bit to do that. You may have to bring in external consultants to help. But that's the worst place for you to start from if you're trying to move in this direction, which is bad news because I know a lot of companies, that's where they're at. But it's not impossible. Usually the best approach for that is to apply what's called the strangler pattern, where you sort of put a well-factored project out in front of this that just has a pass-through that everything goes through into the legacy project. And then you start picking features that don't pass through and implementing those in the new project, until eventually nothing passes through anymore and you can throw away the old project. It's been strangled. Okay.
Yeah.
So now, another question?
Yeah. It's
okay.
from Samir. They say, isn't exposing your domain model to UI or API a security concern?
No, because it's all running in the same process, right? And remember, in this example, I'm talking about ASP.NET Core, which is running on the server. And all these projects are running on the same server in the same memory space, and they can talk to each other without, it doesn't go over the wire. There's nobody listening in. There's no man in the middle attack. If they are able to listen in to the calls between your methods in your server, they already own your server, so you're already host. So again, if we're talking about a UI that lives in a separate space, a separate process, if you're talking about an Angular application, you're talking about an iOS or an Android application or a Windows app as your UI, and the domain layer is a bunch of services that are in a separate process, then that's a whole separate thing. Specifically, when I'm talking about this clean architecture, all these projects live on the same server in the same memory space. And if they still are curious if there's security issues there, then let me know. I can address that further. All right, so let's talk about what goes into each of the projects, and then we'll look at some code and answer more questions. I have like 3 different samples I want to show you, and I know I'm running out of time here. So the core project, what goes in here? This is going to be your interfaces. We talked about those. This is going to be your domain model. That's going to be entities, value objects, aggregates, which is a DDD pattern that I recommend you check out if you don't know it. It's in my DDD course. Domain services live here. Custom exceptions would live here. I strongly recommend that you create custom exceptions for things that might happen, like when you go to call this service, if the customer is null, then it blows up and throws an all reference exception. Well, instead of throwing an all reference exception, create an exception called missing customer exception, or customer not registered exception, or customer not found exception, whatever, right? And throw that instead. So now when a future developer, which might be you, comes along and they see the site blow up, they don't have to scratch their head and say, null reference exception, gosh, whatever could that be, right? Because it never tells you what's actually null. But if they see customer not found exception, they're probably going to be on the right path a lot faster. Your domain events and your event handlers live in core. If you're not familiar with this pattern, again, I strongly recommend you learn it. DDD fundamentals on Pluralsight, we talk about it a little bit. I talk about it some in my podcast, weeklydevtips.com, or on my blog, or email me. But this is definitely one of my favorite patterns you should check out. And then specifications, another pattern we'll cover here in just a second. It's a great way to take repositories that are getting out of control and make them a lot cleaner. So we'll see that in just a second. All right. So then infrastructure project, what goes in here? This is where all your implementations go for things that reference any kind of out-of-process resources. So your repositories go here. Anything repositories use, go here. So if you're using Entity Framework, EF Core, your DB context will go here. If you're using caching, which I recommend you do because it helps in almost every application, your cached repositories would go here. If you don't know what that is, it's another pattern. I have like 3 different articles about it on my blog, and I have a GitHub repo that talks about cached repository as a pattern. So you can Google that. Any web API clients go here. So if you are using external services, your clients for those services would live here. Anything that talks to the file system, anything that's a logging adapter that knows about the details of how you do logging would live here. Any messaging like email or SMS, things like that would go here. Things like system clock. If you need to abstract the system clock for some reason, the actual implementation that uses the real system clock would go here. An example of that would be if you have some logic that needs to run only at certain times of the day. Well, if you just drop a datetime.now into your code, then it's really hard to test that. But if you have an abstraction for the clock, then you could write a test that says, well, if the abstraction tells me it's 3 o'clock in the afternoon, I expect this code to do this. And if it tells me it's some other time, I expect it to do that. And that's much easier to do if you're not tightly coupled to the system clock. You would have any other services that would talk to out-of-process things here, and sometimes interfaces. So the interfaces that would live in infrastructure are interfaces that themselves depend on infrastructure stuff, right? So if you're using Azure or AWS, let's say, and you have some SDK and it has some interfaces in it, and one of the things the interface defines is an S3 bucket or an Azure blob storage item or something like that, you don't want that interface to be in core, because now core has to know about that SDK, and we don't want core to have any dependencies. So you would put those types of interfaces in infrastructure because that's the only thing that should know about those third-party SDKs or types or references. All right. Then that leaves us with the web project. And the web project is where you're going to have controllers and views, or razor pages if you prefer. It's going to have all your DTOs. DTOs are going to be, well, it won't necessarily have all your DTOs. It's going to have these DTOs, right? It's going to have your view models, where if you have just a web API, you typically don't call those view models, you call them API models, perhaps. Sometimes I've seen them called binding models. It's the things that you're model binding against, which aren't necessarily the same as your view models or your API models. Just specific terms for types of DTOs. Any of your MVC specific stuff is going to live here. So that's going to be filters, binders, tag helpers, HTML helpers, all that stuff lives here. And then if you have other services that are related to UI, those would live here as well, along with their interfaces. So if you have interfaces that depend on UI stuff, like you have an interface that takes in or returns a filter or a view or an HTTP context, that's all web related stuff. So it's generally going to live in the web project. Occasionally, some of it might go in the infrastructure, and it's totally okay if infrastructure depends on system.web or Microsoft.ASP.NET Core. That's fine. But if it's specific to this web project and it's not some reusable thing, usually I'll just put those types of things here in the web project. And usually there's some questions around this organization. Anybody asking any? No? Cool. All right. So, okay, what if... Cool. All right. What if you have more than one solution? What if you're a company that has multiple projects, like software projects that it's working on, not Visual Studio projects, multiple applications, and you want to share stuff between them? And again, we don't like copy paste. We don't want to just take that core project and share it necessarily between multiple applications. Each one of these clean architecture solutions maps to a domain-driven design bounded context, typically. And so everything inside that solution is cohesive and makes sense only within that context, within that solution space. And if you need to share things with other applications, you want to have a way of doing that that's very explicit. And so domain-driven design has a term for that called shared kernel. And your shared kernel is where you want to put stuff that is going to be shared between multiple solutions, maybe all of the different solutions and all the applications your company builds, or your division or your team or whatever it might be. And so these shared kernel types are going to be referenced by the different core projects. So I mentioned that core shouldn't have any dependencies. Well, that's not entirely true, right? It's going to depend on the framework. It's going to depend on .NET. And it will also depend on shared kernel if you decide to use one. It's not required. Ideally, these are distributed as NuGet packages. The benefit of that is that each one of your applications can choose when it wants to upgrade to a new version of shared kernel. If you don't do this and instead you do something like, I have a shared project that everybody has as part of their solution, but it actually maps to the same files in source control and on disk. And so anytime they get updated, all the solutions immediately get it. The problem with that is anytime you want to make a breaking change, you have to fix everything at once because it breaks everybody at once. Whereas if you distribute them as NuGet packages, you can make a breaking change. The one application that needed that change can take it and drive on, and the other applications that aren't yet ready for that breaking change can keep on shipping with the previous iteration of that NuGet package. All right, so what would go in here? A lot of base types. So your base entities, domain events, base specification could go here. Any common exceptions that you're going to use across all your apps, common interfaces that everybody is going to use. Utility things like how you do authentication, especially if you do single sign-on, often goes here. If you're going to use a third-party DI container, it's probably a good idea for your different teams to use the same one. So if you're going to use AutoFac, everybody should use AutoFac. You could just put it inside of shared kernel, the references to it. Same with logging, same with guard clauses that are common for everything. And that's pretty much all the things that might go in shared kernel at a high level, right? You probably come up with some others of your own. I mentioned guard clauses. Let me briefly plug my favorite pattern here. This is an example of not using a guard clause. So this is a bad example of what code looks like when you don't use guard clauses. And it's basically a check to see if things are in a good state. Okay, now check this other thing to see if it's in a good state. Okay, now finally do the actual work. So right here, this little comment that says process the order, that's the real work happening in this method. Else, handle that bad case, else handle that other bad case, and on down the line. And if you have more than just these two arguments, this is just what I could fit on a slide and still have it be readable. You can see that this gets really, really deeply nested really quick. Instead, a guard clause just says fail fast, right? If you don't have that order, I'm going to immediately throw an exception. If you don't have that customer, I'm going to immediately throw an exception. And then I know at this point, at the third line of this method, I know that I'm in a happy state. I know I've got all my dependencies. I can just run, right? And so I don't have to have a deeply nested if-else chart to do that. And that's called a guard clause. They're not proprietary or anything. They have that pattern exists in every language. It's just this notion of doing those checks up front. However, they are rather repetitive. And in a large application, you might have the same type of guard checks happening again and again and again. And in that case, it may make sense to have an abstraction for those or a utility. And so there's a number of these that are out there. If you search on NuGet, you'll find different ones. I have one called ardalis.guard clauses, and it makes it look like this. You can say guard.against.condition, in this case, null, and you just pass in the thing, and it will always give you back the same behavior. So you have consistency across your whole application. It's also very easy to add your own guard clauses. So if you have your own domain-specific things that you want to guard for, and you're doing it frequently in a bunch of places inside your code, then you could create guards for those and just use them with the same framework. It'll just be like guard.against, my special validation of this object. Okay, so those are likely to live in shared kernel.
We've got another question.
Yeah.
And I think this is for the slide before guard clauses. It's why would core need to reference DI in shared kernel? Isn't that infrastructure stuff?
That's an excellent question. And so the main reason is maybe, and maybe not, right? But maybe your domain events or some other thing would leverage your DI container, right? It's not unusual to use dependency injection containers in concert with domain events to be the way that you dispatch those events. In most of the things that I'm using now, I've got all that in infrastructure. It's true. So you don't have to have it anywhere in core. The only other reason why you might put it in shared kernel is because of the reuse thing I mentioned. So because these things are used by every application in your team or organization or whatever, by putting some of these things in here, like DI or like logging, you just make it so it's easier for developers to use that thing that's always there and always has a consistent place for them to look for it, than for them to go and grab a NuGet package themselves. All right, so it's about that pit of success and about some uniformity of making sure that all the teams are on the same page in terms of the tooling they're using. And that's really, depends on your organization whether or not that's important. Right, some organizations, they want to make sure that everybody's doing things the same way, because then if a team member moves from one team to another, they're familiar with how they do logging and how they do DI. Other organizations, they're like, no, each team can figure it out for themselves and do whatever's best for them. And both of those can work. It's just if you're using the one where you want some consistency, this gives you a place to put that consistency. It's optional. Okay. All right. So here's where you end up with the solution structure. In terms of dependencies. And so you've got shared kernel at the bottom. It's a NuGet package, ideally. You've got core depending on shared kernel if you're using that. Otherwise, core just doesn't depend on anything but the framework. You have web that depends on core, and you have infrastructure that depends on core. You might have an application layer that lives between web and core, and that would be fine. That's optional. Okay, so what's missing here? Well, there's not a dependency between web and infrastructure, because that's actually optional. But let's just say that there is, at some point, there's going to be some knowledge of web using infrastructure, if only at runtime, because it's going to have to use those types to actually do its job. So at least at runtime, web is going to use those infrastructure types. Okay, and I'll show you in a minute how you can avoid the compile time dependency. Then you have tests, right? So your unit test, you're mostly going to write unit tests against core. It's very unit testable. It doesn't depend on infrastructure. Doesn't depend on web, doesn't know anything about the UI or any infrastructure concerns. So it's super easy to write unit tests for core. And so you're mostly going to write unit tests against core. Then you're going to mostly write your functional or UI tests against web. If you're building an ASP.NET Core Web API, which is a really common scenario, it is extremely easy to write functional tests for that that will test everything about that as fast as an in-memory unit test, just about. And that depends a little bit on what you're using for your data store. So assuming you're using an in-memory data store, then it's super fast. And so this gives you a good way to test the entire MVC stack, right? So you'll know whether your filters work, you'll know whether routing works, you'll know whether your exception handling at the web level works, as opposed to writing a unit test for a controller, which really doesn't tell you any of that. And then integration tests, you'll probably write mostly for infrastructure. So integration tests are things like, okay, I want to see if my implementation of a repository that talks to a database actually works. Let me create a record and insert it and then read it back and verify that it was stored correctly. Okay, now let me update it and verify I get back the updated value, right? Those integration tests of your infrastructure concerns would target mainly infrastructure. Okay, and so that's kind of the whole big picture of how everything relates to one another before we just drop into code. Any questions about that?
A question did pop up. It says, is it a good practice to split my domain validation and the process, or I'm guessing maybe processing, in two different methods?
It's not unusual to have validation be in its own separate class. That helps follow single responsibility principle. I've had good success with tools like Fluent Validation, where you can create separate validators that do a lot of that work for you. Something that comes up frequently in the code that I write is validation that is not exceptional. So there's two types of validation that you'll typically perform. There's validation where if it fails the validation, you just blow up. You say, I can't do anything with this, it's not valid. That's frequently the case when you're doing like request validation and doing model binding and model validation at like the API level. But within your actual business application, things aren't always that cut and dry, that black and white, right? So an example would be I've got a scheduling system, and maybe I've got a rule that says, hey, I really don't want to schedule the same person in two different rooms at the same time, right? Because that would be bad for them. It would be unhealthy. And so if I ever have it something on the schedule where at the same time, Steve needs to be over in room 101 and in room 202 at the same time, that's invalid. But that doesn't necessarily mean I want to raise an exception. Maybe I just want to have it be obvious to the user in the UI that those two things don't work, right? Maybe I'll just paint them both red and let the user know they need to fix it, as opposed to making the screen just blow up and have a yellow screen of death when they drag something and it accidentally overlaps for a moment, right? And so how you do validation sometimes depends on whether or not you want it to throw exceptions or whether or not you want it to just change the state of the system to indicate to the user that something isn't valid at this moment. And in either case, yes, you can certainly separate that validation logic from the sort of happy path of doing the work of the system. Okay.
Another question just popped up.
Yep.
Can we add thin layer combination on top of core and infrastructure layer?
A what layer combination?
It says thin layer combination.
I don't know what that means. So I'll let them clarify, but I don't know what a thin layer combination is.
Cool. Probably move on. They can try
Yeah.
to reword their question. We'll come back to it.
All right. So here's the basic folder structure for the system. So if you're using my template, which I'll show you in a second, it looks something like this. There's three main projects that are the source code, core, infrastructure, and web, and then you might have different test projects for the different projects, or broken up by unit test or integration test or what have you. Let's talk for another moment before I jump into the code about different ways to organize the work that's going to be inside your pages or your handlers in the controller, because this is important too. A lot of times controllers get much bigger than they need to be, and there's a few different techniques you can use to keep them smaller. And the reason why you want your controllers, typically the actions, to be smaller, and the controllers too, is that they're harder to test. The more logic you put in your controller, the more difficulty you're going to have in testing that logic. And the more likely it is that you have other concerns in there that don't belong there, that aren't UI concerns. Okay, so here's your typical thing that you might do in MVC, right? So you're going to accept some kind of type, some view model, some API model, and then in an action, right? And then you're going to perform model validation. Typically, this is just done with a filter. Then you're going to do whatever it is you want to actually do. And then you're going to create whatever model type you need for a response, whether that's a view model or an API model or whatever. And you're going to return that with some result type, whether that's a view or a page or an OK. And so that's what each action does in a controller. Or if you're using Razor pages, that's what each handler would do in a Razor page. Okay, so now let's look at what do work looks like. So option one if you're using clean architecture, is that you're just going to use repositories and entities for most stuff, right? So you're not going to have a separate application layer. You're not going to have separate services that you're going to call to do all the work. You're just going to say, I need to get this entity, I need to modify its state or call methods on it, and then I need to save changes. And so this is really the simplest approach that can work for a lot of things. It's great for simple operations. It works well for CRUD systems where you're just doing create, read, update, delete of stuff that's in persistence. And it requires minimal mapping between your web models and your domain models. Typically, if you're going to have DTOs that you're returning, which for an API you definitely should, for pages or views, it's kind of optional. It wouldn't be the end of the world if you just had your page model or your view model actually work with entities. Ideally, it should be different, but it's not going to have any major impact if it's not. So this is all the simple approach. All right, and so it looks something like this. You have an action method. It takes in something, in this case it's just an integer. It goes and fetches an item from the repository, calls a method on that item, which will change its state, then calls the repository again to say, okay, now update that item, and then it returns something. Right? In this case, it's just returning okay. And that's about as easy and simple as things get. Okay, so now let's say you do want to work with an application service. Maybe it's defined in a separate layer. Usually if I have application services, I just put them in the web project in their own folders. But in this case, that application service is going to return back whatever types the controller needs to do its job. So it typically will return back a view model or a page model or something like that. That's a DTO specific to what that action needs. This is better for more complex operations. It helps get logic out of your controller. The application service is now responsible for mapping. So whether you're doing your mapping by hand or you're doing something with AutoMapper, the knowledge about those types of things is going to live in that application service. And that helps keep your controllers more lightweight. They don't need as many dependencies. They don't need to know about AutoMapper or mapping or some of these other things. Maybe your controller had to know about 3 different repositories before, and now you could have it just know about one application service. Right, so your controller's dependencies get a lot smaller. Now the code looks something like this, where we're doing the exact same thing we were doing before, but instead I've just injected an app service. The app service is doing the same work that I had in here before, where it was going to fetch the thing from the repository, call the method, save it. And if it had to return some type of type that I was going to return, it would return that here. And then I would say return okay with whatever the model was that was giving me. All right, so that helped get my action from 3 lines of code to do the main work down to just 1. So that's better. And for stuff that's more complex, this can be an approach, a refactoring approach that definitely has dividends. All right, so now let's look at this third option. And it's not to say that each one of these options is better than the last. It's more that if you're feeling pain with your approach and you think you might want to relieve that pain by getting work out of your controller, then these are refactoring approaches you might look at following pain-driven development, okay? And so in option 3, we're just going to use commands, and we're going to use a tool like Mediator to process those commands separately from the controller. And the nice thing about this, if you ever need this functionality, is that those commands don't have to only come from that controller. You could send those commands from other things, like from a console interface or from both an API and from a forms-based web application. When you have that command created, you call mediator.send, and it sends the command, and then Mediator figures out how to find the handlers that will work with that command. And then what this does is it makes it so your controllers don't need to have dependencies at all, except for Mediator. And in fact, there's ways that you can make it so that they don't even have to have that, because you can put that on a base class. All right, so here's what this code would look like if you wanted to use Mediator. And you would just create a command. That command would take in whatever data you needed, in this case, that item ID, and you would call mediator.send of that command, and then you return okay. And if it was returning something, you'd get the return type. You could say, var result equals mediator.send instead, and it would work the same way. Okay, but we can make this even better because we aren't really doing any valuable work between the parameters line and the command line. We can use model binding for this. And so if I take in a mark item complete command, and I make sure that the property on that command matches the property in my route, here, this ID that I've specified, then model binding will give me back a mark item complete command with that property set. And then I can just call mediator.send on that command and I can be done. And so this gets our controller action down really small. The only stuff it needs to know about now is the route, the verb, the command that it's going to bind to, and that's it. And so it gives you a really thin controller. The only thing that I would say is even better than this would be if I didn't need Mediator and I didn't need, to have that extra dependency and have a separate handler class. And for that, you can use something I call API endpoints, which I'll show you at the end of this if I have time. But if I don't have time, just look for API endpoints on GitHub under our Dallas. All right. So then let's look at some code and see if there's any other questions while we're going here. So we'll start off with clean architecture. Is this big enough? I should probably make at least my fonts a little bigger. Some people might be on smaller devices. So let's do fonts. 16 is probably good. All right, if anybody complains that it's not big enough, we'll make it a little bit bigger. Let me know. Okay, so in the clean architecture solution template, the idea with this, and let me just open up Chrome for a sec and show you the repo. Let's see, give me a new guest window. There we go. Yep. All right, so we go to github.com, whack our Dallas, whack clean architecture, like that. This is where you'll find this solution template. And so you can just fork it, clone it, download it, whatever you like, and then do whatever to make it your own. It's also available as a project template within Visual Studio. I'm not sure that's up to date with version 3.1. It might still be on 2.2, but that's Greg Trevelek was nice enough to set that up, and so maybe he's got it updated. I'm not sure. But you can use this as a starter for your solutions if you want to use clean architecture. Okay, so what's in here? Well, in core, we have a default entity called to-do item, which you'll just throw away if you're using this as your template, but it gives you an idea of what things look like and how they should be used. So in here, it's using a base entity type. That base entity is defined in shared kernel, and it doesn't have a whole lot going on. It just defines this int ID. If you don't want to use integer types, if you want to use GUIDs, if you want to use both, you can modify this to be a base entity of TID, and then just set this to be the type of your ID, and it'll just work, right? So it's easy to add support for that if you want. Also in here, it's got support for domain events. So there's a to-do item completed event. This actually gets set when you mark an item complete. So if we look at this code here, you'll see on line 15, it says events.add this to-do item completed event. That will actually fire when this item gets saved. And so if you complete this item and then save it, that event gets fired off, and then a handler will be called to do whatever it is that we want to do when that's completed. There's an item completed email notification handler. That's what a handler would look like for a domain event. And so it does a little bit of guard checking. This has built-in support for guard clauses. And then in this case, it doesn't actually send an email, but it could in this case. You'd inject an email service and it would do that. In terms of services, you could define domain services in here. This is just a placeholder, so you've got the folder. And there's some work in here to populate the database with the samples. Then if we look at infrastructure, under data, it's got a EF core DB context. And this is only interesting primarily because it's where we do the domain event wire up. So I don't have time in this presentation to really go into different types of domain events, but there are two main kinds. There's domain events that happen before persistence, and there's domain events that happen after persistence. And any kind of domain events that are going to do things that have side effects that are outside your application, like sending a customer an email, you want to make sure those only happen after you successfully saved the entity that you're working with. And so this is using that pattern, right? So after I save the thing using the default base DB context to make sure the save was successful, then I go through and I find any entities that have events in their collection, and I loop through those events, and I say dispatcher.dispatch each one of those events. And that's what does the work. And so the domain event dispatcher is right here. It's using AutoFac to do some of its work. And there's a bunch of stuff in here that you don't have to know about or worry about or care about. But basically what it's doing is going through and looking for everything inside your solution that uses this iHandle interface, which is defined in shared kernel here, I think. Go to definition. Where are you? It's defined somewhere. Yeah, okay, in shared kernel interfaces. So this iHandle of T, where T is a base domain event, is what you use to define domain handlers, domain event handlers. And so that dispatcher will just go through and find all those types and then call them one by one. So if I come into to-do item and I say mark complete, and when I mark this thing complete, I want to send a notification to email the owner that it was completed. Instead of putting that logic here, which would be very difficult for me to do because I can't do dependency injection inside my entity. And so I'd have a hard time doing that from here. Instead, I'm just going to raise an event. And the idea that follow-on activities that have to occur when this thing is marked complete, they're now decoupled from marking it complete itself. After this entity is saved and it's been marked complete, then the dispatcher will fire, and handlers like this one that handle that event will get called, and they will do their thing. All right.
I had a question about where do the mediator commands live? Which project?
I don't have Mediator wired up in here, I don't believe at the moment. But those commands could live in the web project, if that's where you're doing the wire up, like I showed on the slide. And that's not unusual. But they don't have to. Usually they're not going to have a lot of dependencies, so they could live even inside of core. Right, so you could have a DTOs folder or a commands folder or however you want to organize them. But if they don't have any dependencies on anything else, you could put them in core. The other interesting thing that you might quickly realize is that these handlers for domain events they look an awful lot like handlers for mediator commands. And in fact, you can use mediator for domain events if you want. But whether you do or not, the handlers for mediator a lot of the time can live inside of core as well, depending on what else they have to know about. Right. So if they only know about abstractions and business model stuff, you can put them inside of your core project.
We have another question. Where do you keep your validations for entities?
Usually I'll try and put them in core. Sometimes I won't be able to if they need to know about things that aren't in core, but if everything I need to know about this entity here to know whether it's valid is here in this entity, then I will put that in core. And in fact, that brings up another point that I should make, which is if you can put something in core without breaking the cardinal rule, which is that core doesn't depend on anything else except for the exceptions we've already talked about, like the framework and shared kernel, then you could put it in core. You should put it in core because it's going to be easier to test. It's going to be easier to keep from having dependencies added later, right? So if I've got a mediator command or I've got a mediator handler that does not depend on anything in web, doesn't depend on anything in infrastructure, therefore I could put it in core. I'll put that in core 9 times out of 10 because that means that I know I will always be able to unit test it. I will never have it get harder to test or harder to work with because of dependencies. The one exception to that would be if it's like, even though it doesn't depend on anything, it still belongs in web, like everything about it is web related, then maybe I wouldn't do that, right? Maybe I'd keep that in web so that's where it is when somebody goes looking for it. But short of that, if it's business or logic related in any way, I'll try and push it up into core. And validation generally is full of business rules. So if I can get validation into core, I'll do that every time. All right. That's most of this. I put some container setup in here. So this is just a static class that gets called by startup, but it does all the work of wiring up AutoFac for me here with basically automatically wiring all the types it finds as they're implemented interfaces. This makes it so you don't have to go through and individually set up each and every interface to type mapping. So that can be very handy. Not everybody likes that, this sort of auto registration. If you don't like auto registration, you want to be very explicit about it, you can do that too. I would recommend doing that inside of a module inside of the project where those implementations live. So if you weren't doing something with a static class and a helper method, which is what this is, you could use an AutoFac module instead and put that here inside the root of infrastructure, and it would know about wiring up all of those things. And then likewise, if you have, say, domain services inside of core that depend on interfaces, and you want to wire those up, you would have a different module in core that would know how to wire all those up to your container. All right, that's assuming you're using AutoFac. If you don't need AutoFac and you just want to use startup.cs, that's fine. And then in web, this thing has just a few different ways of doing stuff in web. So it's got some API controllers, it's got some standard MVC style controllers, and it's got some Razor pages. So depending on what type of thing you're doing, you could probably delete 2 out of 3 of those, right? If your typical project is only doing 1 of those things, you can just rip out the ones you're not using.
We have a couple more questions.
Yeah.
Do you use data annotations or fluent validation for the validation?
Yes, sometimes. It depends. Data annotations I use almost all the time, specifically on the API models that I'm using. So I won't put the data annotations typically on my core entities because I don't typically want to expose those to the UI, right? So unless it's a super simple small app that's only used like internally, I will generally have, the web API layer will be a different type, right? So if we look at like to-do items controller, you'll see that when we post this thing, we are not posting a to-do item. We're posting a to-do item DTO, right? And the to-do item DTO is defined somewhere else, not in core typically. And it's going to be here in the API models folder in this case. And if we look at this, it will have, data annotations on it for things like required or max length or things like that. If I have more complicated validation rules, then my fluent validators will probably live in core. And they'll probably be validating against the entities themselves, not against the DTOs that are coming over the wire.
Awesome. And then, one more question. So will you spread commands in multiple layers or stick to one layer? I'll
try to stick to one. That doesn't always hold true, but generally it's easier to follow if you organize them in one place. So that's what I strive to do. And I think most developers would expect to find them in one place, not scattered between multiple projects. The other thing I like, and I'm not doing here in this organization, because there's only so many ways I can organize this code as a starter template. And I don't know how different developers are going to want to go with this. But I'm a big fan of feature folders. And so if this were my project and I had picked one of these, like let's say I was just building a web API, right? So I wouldn't need a separate folder for web API because that's all I'm doing. And so I might have root level folders for each of the different features that this application deals with. And so to-do might be a root level folder. Inside of to-do, I might have a to-do controller. I might have all my commands that have to do with things that you can do with to-do. That sounds weird. Validation, whatever else, everything related to that feature would live in that folder. And then I might do the same type of thing up here. Usually entities will be subclassed into aggregates. And so I would have a folder per aggregate typically, and an aggregate often maps to a feature in the UI. So when I work with a to-do item as a feature at the web API level, I'm probably working with an to-do item entity or aggregate in the core model, right? And those would tend to map, kind of vertically through the slices. Okay, so we can run this to, hopefully I can actually try that because, why would I do that? But if you run it, you'll see it just is a standard ASP.NET Core simple application. And there it is. Let's see. It's on my other screen. There. So this is what it looks like when you first run it. And it just lets you verify that things work. It's got Swagger documentation built in, so you've got all that. It's got a listing of the items, which is pretty trivial. And it has both MVC and Razor pages in here as well. So you can see what these look like in either case. So that's what you get out of the box with this thing. It's meant for you to rip it all out and put in your own stuff. It's meant to be a solution template, not a starter application or starter kit or reference app, right? So any last questions on this? I want to jump to what is a reference app, which is the eShop on web reference that follows the same architecture, and you can kind of see something a little more detailed.
Yeah, there were a couple more questions.
All right.
Where do you suggest to keep business rule validations?
Business role, like security? Business rule. I would put those typically in Fluent validators in core, or I'd put them directly on methods on something, right? So if it's validating that they can do an operation, right? Like, mark complete might have a rule that says, oh, you can only mark something complete if it's not already complete, right? Well, that would be a check that I would just do right here. It's like, well, if, not is done, then, do this work, right? That's a business rule validation. I would just put it inside the entity. As much of the logic as I can put in the entities, I will at first, at least, until it gets to be too big and it looks like it's violating single responsibility. And then I might look for cross-cutting concerns that I could pull out, like validation would be one that would be pretty obvious. But I want to avoid having entities that are nothing but getters and setters, right? So if I pull everything out of this, then I have an anemic domain model where I really just have a bunch of DTOs that map to database tables, and I don't have a rich model that I can work with and modify its state and test and see if it does what I expect.
Okay, and then yes. Is there a project type or size that is simple enough or small enough that you would consider this architecture overkill? For instance, command line processors that move data between legacy systems or something? And if so, how or where do you draw the line?
If I don't need to test it, then I won't use this, right? This is optimized for testability. So if it's something where, for instance, fairly common thing is where an internal application has to access some database tables and modify them directly, right? And there's no business rules. And there's like 2 users that ever need to do this, and they need to do it, once every quarter. And so it's not high use. So you could just take a ASP.NET Core app and just say scaffold, these data entry views for me, and point it at a DB context and point it at these entities, and it just creates them all for you. And you tweak that slightly and you ship it, right? And you're done. You've built a CRUD app, and you can have that done in an afternoon. Doing all of this for a CRUD application like that would be total overkill, because it doesn't have any business rules or business logic. Now, probably it will have those things, right? And so, a few, sets of requirements down the line, you might need to structure it a little better. But at least to start, you can do something like that. Same thing if you've got something that's just taking data and processing. It's a scheduled job or a service that is doing read in data from one source and modify it and put it out to another source, let's say. If you don't need to write a lot of tests for that, then you can just start out by just doing it all inside one console app or doing it all inside of a service. And that's fine, right? And then add this later if you think you need it. But if you have a project that actually would benefit from domain-driven design, then it would probably behoove you to use clean architecture. And so I don't want to keep pushing my DDD class, but Julie and I spend a lot of time talking about whether or not DDD is appropriate for a given project in that DDD fundamentals course on Pluralsight, which again is totally free right now. And so if you go check that out, in the first module or two, we spend a fair bit of time talking you out of using DDD and saying why it's overkill for a lot of things. And if you look at that, you'll kind of get an idea of where it does or doesn't make sense. All right, anything else? Let me pull up eShop on web and pull this up in the browser as well. So if you simply Google eShop on web, you should hit the first hit is this GitHub repo. And this GitHub repo is part of Microsoft's .NET architecture org. And in here, there's a README and there's this copy of my book that you can grab. It's a PDF. It's also available online. You've probably read parts of it without knowing it if you've gone to any of the Microsoft docs that relate to architecture in here. Like if you Google explicit dependencies principle, it's going to probably bring you into one of these things in here where I talk about it, and you can recognize some of these diagrams here. So this is the book, right? But it's just available on the web as part of the docs as well. And you can download it as a PDF for free. So this is a more full-featured application. I don't know if I have it running on here. I literally just cloned it to see if it'll run. I suspect it won't because I haven't run it here in forever. But let's see, we could get lucky. Hey, it works on the first try, as it should. All right, so here's what the store looks like, right? So it's a store for merchandise for .NET stuff, let's say. You can do some filtering on here. You could say, let me just see .NET items. Let me just see t-shirts and filter that. And so here's my t-shirts and hoodies apparently. It has paging. It has, you can add stuff to your basket. It has authentication. You can log in. It's got your login details right here. You can copy paste in. So we'll do that. It's very secure. All right, so now I'm logged in. I can see my old orders, my account. I can add stuff to my basket. I can change the quantity. I can update it. I can check out. It says thanks for your order. It doesn't do payment, but I can go look at my orders, and there's my order that I just placed today. Is it really that late? Wow, it's getting late. Here's my details of what I ordered, etc. Okay, so that's the app. And just so you know, if you're really into complexity and you want to learn about microservices, this exact same app is also broken up as a bunch of microservices where the authentication is a microservice. The list of orders stuff is a microservice. Your shopping cart is a microservice. The catalog of items is a microservice. And that's available at eShop on containers, which uses Docker and Kubernetes and a whole lot of architecture buzzwords to do the exact same app. And so I encourage you to check that out if you want. And it has a whole lot more to it, right? So if we look at this and we see like, what are all the services? So there's a basket service, a catalog service, an identity service, et cetera, et cetera. So you can check that out. The eShop on web is just a monolithic application. It's going to be deployed as a single ASP.NET Core application. All right, so let me show you one thing that's in there, and I'll leave you to explore it the rest of the way yourself. But if we look at the application core, they wouldn't let me call this core because they used core for ASP.NET Core. They didn't like that because it was confusing. So this is the application core in the Microsoft Reference app. But in here, we have specifications. And I mentioned this pattern, and I wanted to give it a little more attention here because I know a lot of people haven't used it before. But you can define a base specification, and it can provide a bunch of features that relate to a query. The most obvious being the criteria. But if you're using Entity Framework, another common thing you'll need to do is define what's included with your result, as well as other things like ordering and grouping and paging and take and skip and all that stuff. And so this specification base class is defined in this sample. And so all the different queries that I just did, like the catalog filter with paging, looks like this, right? And so I can pass into here, skip and take, and whether I'm filtering on brand or type. And then this is the Lambda expression that I need to use for that. And it's defined right here in its own type. So I can unit test this using simple lists of things and see if it gives me back the right values that I expect. I don't have to have it hit an actual database to be able to test it. And I don't have to put a special method on my repository that says get catalog items with filter and paging, right? Because a lot of times you end up with that where your repository has more and more additional specific methods for how to do a search this way and how to do a fetch that way and how to get things this way. And it starts to get big and bloated and convoluted. So when you use a specification, your repository stays really small and it doesn't change very much. So this is the EF repository, and it does everything, right? So it has a get by ID, it has list all, those are pretty standard, but then it has this list async that takes in a specification. And so every one of those types of queries, instead of being a separate method on a repository, now is just passing in a specification to that same generic repository. And so I only need one repository and I just have as many different specifications as I need. And the nice thing about these specifications is they're all in one place. They're easy to find. They're easy to reuse. They're well named. I know exactly what the basket with item specification is doing because it has a name. It's not just this gobbledygook of Lambda syntax that I'm copy pasting from one controller action to the next. It's this thing that I can easily reuse and reason about and treat as a first-class citizen in my business domain. All right, and then there's a bunch of other stuff in here where it's actually doing the work. This is not a sample, this is not a solution template. This is an actual real reference application. So it has real stuff going on in here and you can kind of tear it apart and analyze it and see how it's all working. All right, any questions about that? I assume we're getting close to time.
Yeah, we are pretty much at time.
Okay. There's one last thing I want to reference, but I won't talk about because we're out of time, and that is API endpoints. So if you go to github.com /whack API endpoints, speaking of ways that you can make your controllers much thinner and smaller and not even have to use Mediator, this API endpoints NuGet package lets you create controller endpoints that look like this. So my sample endpoint app might have endpoints for authors. And in fact, I have this open here where it's even prettier. Come in here And the sample is right there. Author endpoints. I have author endpoints for create, delete, get, list, update. So let's look at, say, update, right? So it has a command that's tied to it, right? So it's chained right here with the arrow. There's my command, there's my result. They're all linked together. And then inside update, it only has one handle method that does all the work, right? So instead of having to have a separate handler for this, my endpoint is the handler, right? So this base async endpoint is what I use. I don't need to use controllers at all. This thing actually inherits from controller behind the scenes, but it exposes just a single endpoint that you're going to use. So now you'll never have the case where you've got injected dependencies on your controller that not every endpoint is using, because there's only one endpoint, right? And so if you're building APIs, this gives you a really clean way to make sure that each API is only doing one thing, and all of its DTOs and stuff that it needs, instead of those being scattered around in different folders, like DTO folders or API model folders, they're right here. They're chained to it, right? So they're easy to find. And every single one has two things, a command and a result. So that's all I've got on that. And with that, let me pull up this last resources slide where you can find more stuff. And I'll answer any questions until people run out of questions. Are there none?
We have one at the moment, which I think is relevant, is how can we reach out in case of more questions on your GitHub or other things?
If you have questions about any of the GitHub projects, you can always just leave an issue. That's an easy way to do it. If you're looking to find me, I'm just Ardallis everywhere. So I'm ardallis.com, I'm GitHub Ardallis, I'm Twitter Ardallis. So you can send me an email.
We also put a link to your website and to your Twitter in the show notes on YouTube.
Awesome. Yeah. So I'm very Googleable as Ardallis, not so much as Steve Smith.
Will you have these slides available on GitHub or on your website?
I think they're on SlideShare already, but I can post them there again. So yeah, I'll post them somewhere, and then we can put a link to them on the YouTube
put those
or
in the
whatever.
YouTube notes too. Yep.
Yep.
Great.